Hello, everyone. I'm Sudarshan Lamkhede, Senior Manager, Netflix Research. Our next keynote speaker is Dr. Richard Socher. Richard Socher is the founder and CEO of U.com. Richard previously served as the Chief Scientist and EVP at Salesforce. Before that, Richard was the CEO, CTO of an AI startup called MetaMind, which got acquired by Salesforce in 2016. Richard received his PhD in computer science at Stanford. He is widely recognized as having brought neural networks into the field of natural language processing, inventing the most widely used word vectors, contextual vectors, and prompt engineering. He has over 190,000 citations and has served as an adjunct professor in the computer science department at Stanford. It's my pleasure and privilege to welcome Richard. He's going to talk about building trusted AI with LLMs.
Thank you so much. Thank you so much, and thanks for having me. Really excited to be back here on Apple campus and at BayLearn. I have some various BayLearn t-shirts that I still wear a lot. So yeah, I want to talk to you today about building trusted AI with LLMs. And before we dive in, I want to zoom out for a second and actually acknowledge that we're currently in this interesting AI paradox. As the marginal cost of intelligence goes down, some people think, well, will we just lose our jobs and use less of our own intelligence? And I think we can actually look a little bit at history. And there's this gentleman called Jevons, who in the first industrial revolutions found a somewhat related paradox. And what he realized is that as a lot of smart people at the time were working on making steam engines more efficient and trying to identify upper bounds of how efficient you could possibly make a steam engine and transfer energy from coal, they thought, well, as we're getting more and more efficient steam engines, we'll need less and less coal. It's going to be, like less of a reliance on coal. But really what happened is they just used more steam engines in more places, right? And they would do more different things. And I think we're seeing something similar with AI right now and intelligent processes, namely that we'll be able to use intelligence, broadly construed, in more and more places. And in fact, at some point, we can look at what wealthy people currently have in terms of access and think about where technology can get into those fields, and then we'll have much more equitable access. For example, since we're here at the Apple campus, like a middle-class teenager and a billionaire use the same iPhone. But a billionaire will still have a personal tutor for their kids, a personal healthcare team for himself and his family, a personal assistant that will do all kinds of things that require a little bit of intelligence. You don't need to have a PhD to book someone a flight and schedule meetings and juggle a calendar, but it does require some intelligence. And we'll see that with AI, we'll get more and more access to those kinds of goods and services that currently are only available for very wealthy people. But there are also some issues that will hold us back. And we want to go a little bit into those, and they're broadly construed as trust. LLMs are, by default, not trustworthy enough for us to use them a lot. I'm sure many of you have seen several of these examples, but it's quite interesting, right? Even a company like Google, who's invented a transformer and has done a lot of incredible research in a lot of places, will tell people to maybe try at least one rock a day to eat for their health. Don't do it. Not a good idea. On an even more serious note, Microsoft, who literally owns half of OpenAI, worked with the city of New York to help restaurant owners and landlords and so on answer questions about their business, how they should conduct themselves. And if you had actually listened to their chatbot, you would have broken the law, discriminated against poor people illegally, and so on. And it's kind of nuts that they probably got a lot of money for this very specific custom project, and yet messed up in several pretty serious ways. You can maybe say maybe this was for political reasons, like they can't answer this. But if you ask simple questions like who won the 2020 U.S. presidential election to Microsoft Copilot and Google Gemini, they're like, I'm still learning. I don't know how to answer this question. It's not that hard. Now, every day when that happened, I go to U.com and I'm like, maybe we're also failing. Maybe there's just like a fundamental problem with this and we're also screwing up. But in each of those three cases, we did just fine. We tell you don't eat rocks. We tell you don't put glue on your pizza. When you ask, like, should landlords have to accept tenants on rental assistance in New York City, we even correctly cite the right sources of the NewYorkCity.gov website, which is even publicly available. You didn't even need to have to do private custom RAG. All we had to do is just build the technology for a few years and do a lot of engineering, and I'll go a lot more into the details of what this will look like. And of course, who won the president's election? Not that hard. Lots of good citations and images to underline this. And indeed, these aren't just sort of some cherry-picked examples. When you ask a lot of companies what their main risks are that they see for really getting generative AI and LLMs into their company context, inaccuracy is indeed the #1 concern for most of those organizations. And I think it is a little bit, nice to come right after Drago, akin to various other areas of AI that we've seen in the past. Especially now with agents coming up, you have to think about if an agent is like 95% accurate on each step, then after like 14, 15 steps, 0.95 to the power of 15, it'll fail half the time. After 30 steps, it'll fail almost every single time. And so we have to kind of go from, okay, there's 95% accurate, and in the case of LMs, often like 50, 60. In the case of our competition, spend a lot more money on marketing rather than on the technology. You do need to spend a lot more on actually getting it right. And we've seen this with self-driving cars. I still remember, and I started investing in startups after my first startup got acquired. And I had friends who said, oh, we're reinventing the car. It's not even going to have a steering wheel. And I'm like, oh, man. I mean, yes, you've raised like $300 million in your seed round, and it's extremely impressive, but it's going to take a lot. And it's not an ideal setup, right? You have to be accurate every single second for hours and days and months on end. And never have a steering wheel means you can't even collect the training data in some virtuous cycle the way Tesla is doing. And basically, you spend a lot of money on a Tesla, and then you're a free data labeler for them. That's really brilliant, right? That's a very cost-efficient way to collect training data and make money in sort of this virtuous data cycle. And if you are a self-driving car startup that doesn't have any of that, and you don't even have a steering wheel, it's like, how are you going to do all this nice transfer learning and get human feedback and RLHF and whatnot? So I ended up not investing in any of those companies, and most of them kind of got acquired, some sort of more ceremoniously than others. But I do think we have to acknowledge here that we're in a space right now with Gen AI where it's very easy to hack up a prototype, but it's still actually quite hard to get that prototype in production at scale for insurance companies, healthcare companies, fintech, biotech, hedge funds, and all of those kinds of organizations. And so one thing that we've also realized, and it's kind of interesting with all the antitrust stuff that's currently going on with Google, I don't know if people saw that, but the DOJ basically recommends to split up Google and force them to offer APIs and things like that. It's pretty serious recommendations that they're making. But really, a lot of normal people don't even have super complicated needs. This group here in this room are what I would call mostly is full of knowledge workers. You do have very complex informational needs. But one thing I've noticed after working in search for a long time, that there are a lot of people who just ask, like, what's the weather tomorrow? When's Thanksgiving? Who's like the president of France? How old is Obama? And most of those questions, there's nothing you can do to be 10x better than Google, right? Google will give you that answer within 1 second. You can give that answer with an LM within 1 second, maybe 2 seconds, but then people don't see a 10x experience. Where they do see a 10x experience is if you can actually replace 10 Google searches for them and do all of that and then put all of that knowledge together. And that's why we've built what we're now called custom agents. And maybe I'll show you a few demos just to give you a sense of the underlying technology that we'll jump into and what that actually looks like in practice. You can do simple things like, who's Richard Socher? That's me. You get like a simple answer with a couple of citations and stuff like that. Then it gets more interesting. We're actually the first, as much as I love natural language processing, I've worked on it for over 2 decades, but if I ask for a stock price, natural language is not the best modality to answer that in. So in early 2023, we actually started making multimodal chatbots and say, all right, for stock prices, you want to have an intent classifier, and that intent classifier will route things into different directions and do a lot other things that we'll get to in a second, like dynamic prompting and so on. But what's interesting is when you now say like Salesforce stock price, and then you ask a follow-up question like, oh, who's their CEO? Now, what happens for a lot of companies that build a demo and be like, how hard could this be? We can just take an LLM like OpenAI API, and we'll have our own chatbot. These are all just very thin wrappers. We don't need them. Then they take who's their CEO and they throw that into their search engine, and then they're surprised, that they don't get any results back. Because if you just throw who is their CEO into your search backend, you're not going to get the right result about the CEO of Salesforce. So you need to do query rewriting, and that in itself is also a pretty tough to get right module as the conversations get longer and longer. And you need to rewrite that query in more and more different ways. There's more and more ambiguities. Maybe at some point like the user talked about multiple different companies, and you need to now kind of make a guess of which one are they referring to when they ask for their CEO. And then the search backend needs to give you, so the right set of answers back. So it's another one that's kind of interesting. And this is kind of where I think we're going to see more and more where this technology can really shine, namely in much more complex informational needs. So if you work for a VC firm, for instance, and you're getting tasked to write a report on tell me about robotics, the impact on geopolitics, economies, and the global supply chain, right? So non-trivial things, where this isn't just like one Google search and then you're suddenly knowledgeable about answering that question and writing that essay. Then you can actually go and get these very nice long form answers where every single sentence has a legit citation and so on. And this one here was particularly fun because I showed it to Jensen Huang, and he said, oh, Peloponnesian War, did your report mention Thucydides? And I'm like, oh man, he's going to have a n equals 1. I have one shot to wow him. And fortunately for us, at the very end, indeed, Thucydides was mentioned in the history of the Peloponnesian War, and I was like, wow, he really knows his ancient war history. And I was very glad we got that right. But when you look at these kinds of things here, there's another really interesting one, which is citations, right? So here you see every sentence has a citation, and we saw a lot of folks kind of ostensibly copying that feature, and then we did a study. And I won't talk about that too much, but in the study we looked at 500 different citations and checked actually for us and different competitive offerings. And we looked at how often is the fact that the citation is supposed to corroborate and actually be a citation for actually mentioned on that link. And it turns out in some of our competition, half of their citations are just random numbered links behind sentences that have nothing to do with one another. And you're like, that's how you do our, make it faster and seem more legit. But as companies start to evaluate and run actual bake-offs, that becomes more apparent. Most companies don't. Now, what's interesting here is when you click on these citations, what we do, and I don't think anyone else does yet at scale anywhere else, is we actually scroll down and mark exactly where we found that fact in the browser. And this works on all Chromium and Safari-based browsers. And that helps you to trust but verify. And to me, Gen AI is often in a place where it's really useful when it would take you a very long time to create a kind of work product, but it's very fast to verify if that work product is actually useful or accurate or good, right? It would take you, for instance, a long time to create an illustration, but you can look at an illustration quickly and say, yeah, that looks beautiful, it's ready to go. But if you get a very long essay, and now half of the citations aren't quite right, your career depends on not goofing and telling people okay, yeah, this is their revenue from last year and so on, and then it's a different number and you can't verify it, then you don't really save that much time, and then the whole technology kind of starts to get questioned. And we've seen this now of some companies that thought 2 years ago, wow, I can just fire half of my people right away, it's amazing. Then they realized, okay, well, this ChatGPT doesn't know anything about my company's context. Then they said, they were told, I just fine-tune it on my own data, and then it will know everything. And then they realized, okay, well, now it's hallucinating well about stuff that sounds like it's from my company, but still not accurate. Then they were told, we can just quickly prototype some RAG solution, and then it'll solve. And now they're getting tired. They're like, this is just like, it's all hype, and the technology isn't working well enough to really be used inside our company. And so I think it's important for us to not overhype. I'm one of the most excited people about AI. I've worked on it for 2 decades almost. But you need to be a little bit more careful about how you communicate the timelines. Long term, I think there are all kinds of amazing upper bounds that we can get closer and closer to when it comes to the different dimensions of intelligence. But right now, it will take a lot more careful engineering on a lot of these. And where we found a lot of folks really enjoying this technology is especially when it comes to sort of research work and analysts' work. We were told by a customer, actually, they asked this question, that this literally saved them several hours of time, this particular report, which, it's hard for me. It is a very, very technical report in biotech. But yeah, you can also say, I want these only from Nature journals. So this is something very interesting too. And then, it'll basically just make sure that all of these citations actually come from Nature journals. So if you're a researcher and you want to just get, citations from legit sources, you can just say that in natural language, which is pretty exciting. And then maybe as one of the second to last demo, this one was really incredible and kind of surprising, honestly, to me too, that it worked at all. This was the question that a user sent us and asked, did you kind of know I could ask this question, or did you hand tune the system to kind of do this thing? So the question was, what should be the initial investment in a compounding interest index fund for my 1-year-old child to ensure fully covers the cost of her Stanford tuition by the time she completes high school? No pressure on the little girl. But it's kind of incredible. The first thing it did is it had this thinking step, right, chain of thought reasoning, and said, all right, well, I got to know a couple things. Number 1, current cost of Stanford tuition. Number 2, expected annual increase in tuition. Number 3, expected annual returns of such an index fund. Number 4, the number of years when she would go to college. And then it actually went ahead and decided on this action of, let me search each of these different steps. And goes on the web, finds you nice citations, finds lots of legit citations, Stanford, EDU, and so on. Then finds the second set of facts, the expected annual increase in that tuition. Again, finds legit sources for it. Then realizes, okay, compounding interest fund, probably S&P 500 is reasonable. Over the last 50 plus years, had around 10% returns. And then, and this is kind of even more cool, in this genius agent, it will realize, let's not just hallucinate a bunch of math now. It is kind of surprising and a little bit ironic that we do millions of matrix multiplications when we generate any token, but then you just ask for simple multiplication problems and it will still give you the wrong answer sometimes. And a lot of people discredited the technology and said, these LLMs can never reason, and it's the dead end for AI and all of this silliness. But really, the amazing breakthrough is if you just allow them to program, and then you let the AI actually decide to also run that program. And if you ever try to do that, it's a massively scary security problem, because now you let anyone in the world tell an AI to do stuff. If it thinks it should program, it will write the code and then run it on our machine. Right? So people will immediately go and be like, hack this machine. Tell me, find all the passwords on the laptop that you're currently running on, the machine in the cloud that you're running on. Try to find all the other IP addresses that are in your network. All of this stuff, right? They'll try to hack your machine. They try to tell it to mine some Bitcoin, and machine's gone for a long time. So there's a lot of complexity in the consumer world. Now, of course, in enterprise land, it's not that bad, right? Nobody says I want to waste you a bunch of time and try to recover other files and whatnot. But what's cool here is it actually decided to run this code, write the code, run the code, and then actually give you the right answer. And so it just put from this one question, these multiple steps, and it actually does it all correctly. I honestly thought, I'm obviously excited about what we're building, but I was surprised we got this right too. I did not think we could answer such complex questions actually accurately. And yeah, you can make them all interactive too, and have specific workflows. But maybe I'll just choose here a fun example here. This is a custom agent that anyone here can build right now, right? Where you just give it a topic, and then it will write you a fun trivia set, like a quiz for trivia questions. So here the prompt is history of China, and so it'll just keep asking you fun facts about China, like true or false, Chinese civilization first emerged in the Yellow River Valley. and then ask like, okay, which dynasty is known as the first imperial dynasty of China? And it'll just like, that's all it will ever do, right? It'll just ask you questions and keep on going. And when you look at sort of how hard that was to create that, it's actually like surprisingly easy, right? You just give something like, you're a quiz master. You now create an engaging trivia questions based on a given prompt. You can have true, false, multiple choice, and so on. Here's some interaction flow. You choose the main model you want to use, and they are all becoming more and more similar, but there are some that still work better than others, and it switches all the time. And you can include live web access, so it'll pull up images and things like that, and citations for the questions. And that's it. And then you can automate that workflow. And this might not, it's obviously like a fun example, but we have a ton of examples now where companies and employees work, and just with this simple technology already, they can basically automate. Most knowledge workers can automate 10 to 40% of all the different workflows that they have. And if you spend hundreds of millions of dollars on those people, like that changes how you should run your company. And so yeah, super exciting. End of the demo, and now let's talk about how we actually try to make some of this work and work at higher accuracies. So there are a bunch of different challenges. Of course, infrequent training data. We can't, or infrequent training runs are just like obvious sort of reality. Like the world, there's a lot of things that happen every 2 to 3 minutes in the world. There's news that comes out. No one's been able to train LLMs every few minutes and then actually infuse all that knowledge. Lack of transparency of the source and attribution of those, and then these complex reasoning tasks. And there are a bunch of different modules, and obviously can't quite tell you all of them and all the details of all the code. But here are just a handful of them that we have worked on, and each of them very often is its own kind of AI project. And you think, ideally, and I thought this too, ideally, why can't we just use the LM for all of these things, like intent classification? Like it's basically just ask the LM. But it turns out you have to, in some cases, especially for the intent, when the query comes in, the very first step, you have to be extremely fast and extremely accurate. And the LM will just not be fast enough, and a lot of other modules are blocked. Once you know the intent, then you can start parallelizing a lot of things and start searching with everything, start creating background information, you try to start constructing the prompt dynamically and all of that. But that very first intent classifier, for instance, has to be much faster than an LLM. So I already mentioned the intent understanding, is one of the first steps, and then you can route it. And in some cases, again, as amazing as LMs are, they're not the best way to answer certain kinds of questions. Now, the second big thing is that you kind of have to rethink the search stack. In many ways, LLMs are amazing, but they're kind of garbage in, garbage out types of situations, right? If you put into their prompt a bunch of outdated facts, they'll just start citing and using those outdated facts. And if you give them more context, they're more likely to actually find the right facts inside that context, and hence be more likely to give you the right answer. And so what we've done is rebuilt a stack for search that will retrieve at very high speeds much, much longer snippets for all the links that you would get. And right now there isn't really a very good web index, like search index for the web, right? Microsoft Bing was for a long time kind of the only monopoly that offered an API that you can use very efficiently. But then they crank up the prices like 5 and 20x, like on different types of their API. So that kind of went away for most consumer use cases. It's just like was infeasible to use. Google doesn't provide an API. They may have to in the future if antitrust works out, but like right now they don't really offer a great API for it. Now, a lot of companies will sit on top of Google through SERP APIs. They actually have lots of proxies. Then they send their query to those proxies. The proxies pretend to be users, scrape the Google results page, and then send it back as an API to folks. And that can be done, but then it's a little bit slow, right? And you want these things to be really, really fast. So we have to build quite a bit of that search stack ourselves and have much longer snippets. And what's interesting and exciting actually from that is that you can evaluate these and actually end up being more accurate than these Google SERP APIs or the Bing API, just by virtue of having many longer snippets for each website. And that's just more likely that the right answer is in there. And you can evaluate that properly on academic benchmark data sets, where the idea is, I'm sure many of you know Squad and these other data sets, they usually have a paragraph from Wikipedia or somewhere. They have a question, and then they tell you the answer is a specific phrase inside that paragraph. And the way we evaluated this on these data sets is we just deleted the paragraph. We just asked you the question, and then we asked the search backend to get us all the information from the web to answer that question, and then see how often in the search results do you actually have the right snippet that was the officially right answer. And so if you run that evaluation, if you just make the snippets longer and give more of them per website, you can actually beat even Google and Bing as a small startup for that retrieval accuracy. Second one is the citations. It's one of those things where you're like, oh, we'll just do some n-gram overlap. How hard could it be? And then you dig in, and it's actually also highly non-trivial, because in some cases, citations will basically contradict each other. Right? You have two things that can't both be true at the same time, and then the LLM has to go back and say, well, people don't agree on the answer here. There are different, contradicting sources. Then, of course, when people talk about even the plague here from this Peloponnesian War example, there was basically different dates and different years even. I think this one, for instance, mentioned it was 429 and the other one was 430. And then you have to kind of decide which one do you use now. Do they actually refer to the same event? Because if it was an assassination or something, then the year is pretty specific. But if it was a plague, then it probably was a year long back then especially. And so it was probably the same plague that they're referring to, and that had a different cause. So you need to decide whether you merge slightly different or exactly the same but phrase differently facts into one citation and one reference. And so there's a lot of complexity in details as you're trying to get this technology to be really trustworthy and working well. This one was a fun example, actually. A researcher not affiliated with U.com, he thought, oh, I'm going to use Google Gemini and fact check U.com. Because I kind of jokingly had tweeted, did we solve the hallucination problem? I could not find a hallucination in our research mode for several months now. And so he took this S1 filing from Reddit and our summary of it, with a ton of different numbers that were mentioned in it, and put it into Google Gemini. And then Google Gemini actually said, no, there's a mistake here. This is not accurate. According to Reddit's December 2023 user metrics, the platform had 52 million daily actives and so on. But actually, it turns out their fact-checking of our result was wrong. And indeed, if you go to the SEC filing, you go to New York Times and so on, and you look into all the citations, you actually realize this was this entire S1 filing summary with tons of different specific details, everything actually checked out. And again, I think getting these citations to actually point you directly to where they found the facts is a huge unlock if you're a knowledge worker. Then you can have inside your LLM orchestration layer kind of a whole routing system where you decide based on the kind of question that you have, which LLM you should route this to. And even if you are in one organization, like Google or OpenAI or somewhere, you have different models within that organization, and you don't need always to use the most powerful one if the question is a lot simpler, right? You can just save cost and time and route it to a completely different LLM. Maybe at some point we can also have that deeper in the stack, and LLMs are even more mixture models and can completely gate certain paths of it. But for now, the space moves so quickly. A lot of companies struggle with this, and a lot of companies also say, "Oh man, I just got this 1-year contract with OpenAI, and now Anthropic has the better model, and now I'm stuck with this old model that's not as good." And so we kind of abstract all of that complexity away and do the model routing. And then this one is a really fun one, is dynamic prompting. Now, of course, in general, as you have a search stack, the search stack gives you a bunch of facts, and then you feed those facts into the prompt of your LLM. That is already a form of dynamic prompting, but it gets even more dynamic than that, in the sense that you also want to encourage the model, by default for us, to like cite your sources, right? But if someone actually says, oh, I just want to write a poem for my wife, then you don't need a citation behind every line of that poem, right? It feels kind of not legit. And so you want to basically change your prompt based on all the potential intents that a user may have. Might they want to program? Might they just want to jam on an idea and be creative? We will be actually one of the few sources that or sites that will tell you, like, we don't know. This fact cannot be found online, as far as we know, and not answer the question. A lot of folks will then err on the side of, let's just hallucinate something. So we pretend to be very knowledgeable, but we feel like it's better to also allow the model in the prompt overall to just say, I don't know. So this one is a fun example here. Like, are strawberries berries? Fun fact, biologists actually say they're not technically berries. They're called aggregate fruits. Who knew? And here are the citations for that fun fact. But then if you say, now write a story about a strawberry that actually wanted to be a proper berry, then they will just do that and will not cite any facts in that fun story. And then you can kind of configure all of that. I think it's not as interesting. I think this tool use one is super exciting. Right? Ultimately, most of these models are just neural sequence models. And I'm very excited. It sounds like kind of reductionist, right? Predicting the next token and all these sequences, but it is so incredibly powerful. And like 2019, we started working on sequences of proteins. We actually synthesized those proteins back at Salesforce Research and generated new kinds of proteins, right? And right now, a lot of folks are excited about sequences of actions and clicks, and of course code, because code, basically allows you to do most things on the web. In one form or another. And so giving these LLMs the ability to use different kinds of tools, run math, do logical reasoning, really unlocks a ton of incredible sort of use cases. And right now, a lot of folks are excited about agents. It's essentially just another form of neural sequence models that includes clicks and other actions. And yeah, this one was a really fun sort of math example too, where I was surprised how poor a lot of LLMs did, and didn't quite realize that you'd have to just write code and run that. Now, maybe as the last major section here, these were all sort of the inputs, but what about the outputs? Like, you have to evaluate this, and it's actually a lot harder, right? If you've been in machine learning for a long time, and in the early versions of this conference, right, we always used to have a nice train def test splits, and it was just clean, and you knew I was making progress on this data set. And now everything changes all the time. It's really hard to evaluate it. There's just so much complexity. And as things are so dynamic, it gets really hard to evaluate. You change the prompt. Now you don't have a nice, beautiful single test set. And with that prompt, everything is better, that new change and whatnot. So I do think there are sort of ultimately two levels, right? There's sort of intermediate properties that you want to evaluate, and then there's the overall user preference. And so we've done this study here where we paid actually a company called Invisible Technologies, so that we're not biased and ask do you really not like this answer better, kinds of things, and just have them run that evaluation for us. And honestly, I was hoping, this is a few months ago now already, I was hoping that we'd just be less accurate in ChatGPT-4, so we're engineers, and we say, all right, we'll make it more accurate, and then we also get 100 million monthly active users. Unfortunately, for us, we're already more accurate than them, so it's clearly not about that, right? It's clearly more about marketing and so on, which is not this conference is not about that, but know that if you ever do a startup and you think you're going to win just because you have the best and most accurate AI, that is not the case. You do need to do a lot of marketing and sales and distribution, but I digress. So basically, this is what we got out, and you might say, and I'll mostly focus on the stuff where we have all the details, but there are a few other folks that actually have run these evaluations. This one was another company, Andy here, that worked together with one of their YC friends. And so, of course, they kind of came out on top. But if you discredit that connection a little bit, then people do actually see, wow, like u.com for this other startup is also a lot more accurate than all the other ones. I understand you would take these with a grain of salt, but this is sort of my academic hat. I was actually just trying for us. I didn't think I was going to talk about this. I just wanted to see how can we get better and where should we improve. And so it boiled down to essentially looking at these 5 different dimensions of LLM answers. Right? You can look at the clarity, like is it using precise language and logical structure and so on. Formatting is also surprisingly a major effect. Right? If you don't have nice bolding and nice headlines, people very much dislike that answer. Then you want to be comprehensive and fully address all the aspects of the prompt and the question and so on. But you also want to be concise. Those two are actually really hard to beat everyone on both simultaneously, right? Then what I think is one of the biggest ones, the most important ones, is the accuracy, and then just being faithful to kind of the prompt. Like if the prompt says, explain it to me like I'm 5, and you're using a bunch of crazy terminology, then you're not faithful to the prompt. And so we did all these evaluations through Invisible, that company, and this is where we came out at compared to ChatGPT-4. There's like an overall slight preference. There's a massive gap in accuracy, but also we're much less concise. That's what I mentioned with like comprehensiveness and conciseness. And clarity was pretty much the same. I already talked about the search backend that you can evaluate too. But yeah, so where does this really shine? It ultimately, the more complex your search needs and your informational needs are, the more this will kind of be helpful. This is a company called Elucidata. They had run some of their own RAG and reasoning capabilities over a bunch of different experimental data sets, fairly complex, like hundreds of different CSV files and spreadsheets and figures and plots and so on. And then they sent us 100 questions. Honestly, some of these questions were so complicated, I didn't even understand the question, let alone be able to answer it. And they did not send us the answers. And so after like working on this and being able to incorporate all of these different things, which is kind of an interesting side note here, actually, Google Gemini says, oh, we have, I think, a 2 million token context window. And you say, wow, that is like a huge breakthrough, huge step forward. And then you realize like that's one 5 megabyte file. And most companies have more than one 5 megabyte file that they want to get answers over as they even drag and drop them into the browser. And so yesterday we actually announced like 50 megabyte file uploads now. And part of that work was also what we had to do for this partnership with Elucidata. And then I was kind of surprised, and it's honestly kind of scary, but they said when we sent them back the answers, like, you actually got all of them right, which is almost a little bit weird. I'm like questioning their evaluation a little bit. But on very complex questions, you can do more and more interesting and powerful answers. And maybe as a last example here, this one was really fun. Guardian Recovery helps a lot of people with addiction and mental health problems. And they literally told us, like, you're saving lives, which was kind of beautiful in the sense that we just streamlined so much of their documentation and boring administrative tasks that ultimately they could spend much more time with patients and hence actually help them a lot more. And this is, again, it doesn't feel like, oh, like everyone's losing their job, everything is different, right? But it is very meaningful if you can take out 15 minutes every day for each doctor away from these boring, repetitive tasks. And so yeah. With that, feel free to try out U-Pro. I hope it wasn't too promotional, but all these facts and distributions and data sets and so on were real, and we did not try to modify any of them. And yeah, thanks for listening, and open to answer some questions.
Thank you, Richard. I think we have time for a few questions. We'll be happy to take those live. Let me know. I can pass on the mic. Okay.
Hello. Yeah, you mentioned some of one of the big challenges you have is actually coming up with good citations. So can you elaborate a little bit on what you changed, how you're doing it?
Yeah, so pretty non-trivial. The first thing is you got to have a good search stack, And a lot of companies that kind of started after ChatGPT came out just were mostly focused on the LM. But again, like LMs are garbage in, garbage out types of situations. So the better data you can feed to them, the more you can trust the sources that you feed into it, the more likely you'll have better citations. So that is a huge aspect that a lot of people just don't spend enough time on. And then going into the details and trying to actually get to identify the facts and then where each comes from in this way is also non-trivial. But you can kind of see, here's actually, sometimes the browser deletes it and sometimes it doesn't. You can kind of see how we did that, at least like to some degree technically. In the link, you can kind of say, where did I find that? Now, that also will be a little bit slower. So there is a trade-off. We don't always do the exact marking of where we find each fact. We have different modes, like there's smart mode and research mode. In research mode, we always do it. In smart mode, we don't always do it. And so you kind of have to do a trade-off there. Then we actually, and maybe this I can't like give you the full code or something right now, but like you just have to like run A/B tests. There are actually trained f-test splits and things like that you do need for those citations to get that right. And in some cases, I have to say, yes, the marginal cost of intelligence is going down, but some users have like unrealistic expectations. Like one guy yelled at me and said, "Oh, I asked this question. I know your answer was incomplete. And you're bad for giving me an incomplete answer." And I'm like, "Okay, what was your question? Let's talk about it." And they're like, some weird thing like sports stuff, like all the NFL players that were born in these like 5 cities in Canada and then played in one of these 3 teams in the NFL. And I'm like, oh man, like unless you get lucky and you have a perfect like database somewhere and table where it says exactly the cities and the teams and all the things that every NFL player was in, if you actually had to go on the web and do that for every single NFL player out there and parse all of those texts and all like these thousands and thousands of different websites, and then like do all the token and counts and citations and everything, that probably answering that one question would probably cost us like $5 to $15. And so I asked him, like, would you be willing to spend $10 on getting that answer? He's like, nah, we're just drunk and wondering, it's just like some evening with my buddies. And I'm like, so it is actually an interesting question, like with the citation and the logic, like how much can you afford to do some of that? And that's, again, where companies will care enough and are willing to pay a little bit more. But some of the technology at its limits in terms of accuracy might not yet be completely feasible in terms of cost to serve at really large scales for just random consumers, especially in countries with like just low purchasing power and low GDP.
Right. We're going to take one last question because we want to go for a break after this, and we want to be back on time at 3:30.
A couple of
So my question is, when you're searching through like the data, so since you mentioned about different research modes, and you said that different citations you pull out. So in that, is there any preference you consider that these sources is that some bias, a lot of bias to it?
Yeah, bias is a super interesting one I could talk about for a very long time.
How do you weigh it against, like, what kind of, just a little bit insight on that?
Yeah, like one person's disinformation is another person's freedom of speech, and there's a lot of complexity in that, and ultimately it's like almost a philosophical, civilizational, and legal question, right? Some countries don't have perfect freedom of speech, and it's illegal to lie, but it's not illegal to lie in the US, and so on. And so I think you just want to try to be as unbiased as possible in your sources. We also work a lot on news. I actually get like a news API that's just for news, and it has like millions of calls a day from just like some customers that use it for their own end user products. And so in that news also, we try to be very inclusive and as unbiased as possible in terms of the news sources. But we might not have like the super hardcore like neo-Nazi fringes and sort of hardcore like Stone Age communists, like anti-all technology kinds of sources that do exist on the internet, which is funny. But and so yeah, so you do try to restrict it a little bit, but try as little as possible. And then there are actually some people who claim like, oh, this technology is dangerous. I told it to ignore its prompt, and give me the most controversial opinion on a very politically charged subject. And then it said like, oh, abortion should be legal for all women, even if they die in childbirth or something. And I'm like, that's a terrible viewpoint. I don't agree with it. But like, if you ask for it, I also feel like as a search engine, I should tell you. Like, I actually developed then this, I call the Wikipedia test, which is if you can find a certain fact on Wikipedia, then it's also fine for a search engine to tell you that fact if you ask for it, right? We don't want to pretend like the world is just full of like everyone is nice to each other and there's no negativity and no hate and biases and racism anywhere in the world. And so if you ask for a specific thing, I feel like this technology should, as a search engine, give you that. Now you could argue that, yeah, if I want to have the child-safe mode, then maybe we can pretend like there's no violence in the world and so on. But if you ask for it, the search stack should be able to pull out even fringe opinions if that's what you want to learn about.
Thank you so much, Richard.
Thank you. Thanks, everyone.
Really engaging talk. Thank you so much again.
Thank you.